Good afternoon, everyone. What I'm going to be going through in this video is I'm going to be talking about developments, and I'm going to be solving two of the developments, the last two developments we had in our drawing pack. So just to start off with, I will open open that drawing pack that I had it open previously, but I have to open it again now. Okay, so we're going to do development 3 and development 4. And the thing that makes these developments harder than development 1 and 2, so 1 and 2 are pretty similar. The difference is that with 1, all of these corner pieces are all the same length because the thing's symmetrical. Whereas here, the difficulty comes from the fact that the seam is not a true length. Even if we draw a line down here, the seam is not a true length. And that these lines are all different lengths, so we have to calculate more true lengths. So that's what makes that difficult. Whereas in this question, the thing that's difficult is that the top face and the base are not parallel, and that makes this noticeably more difficult because we need to draw two sets of lines for heights. And in this case, for the seam, we actually need to draw a third line. So we have heights to here, and heights to here. To different lines. Now I'm going to bring that over. Now that I've shown you the question, what I'm going to do is I'm going to just now I'm going to show you a 3D model of the object that I've made and I've labeled. So this is development 3, and you can see that this is what it looks like in view. I'll just rotate a little bit so we can get a sense of what this object looks like in 3D space. Okay. And I'll just rotate it a little bit further just so that it'll let us the right direction. Okay, so to solve this, I have done, I've solved this here. Now this is sort of it's not the minimum that we need, but this is me annotating. So this is the question that we're given. This is the stimulus for the question. We're given this information here. We weren't told this height here is 30. I decided to make it 30 just to make it a little bit easier for me to draw. And then this is my solution. Now, it's important to remember that you don't need to measure these distances that I've shown you here as the colored lines. You don't need to measure those 4 lengths. And the reason you don't need to measure those is because you can use a compass, and you can just measure that across and then just put it straight here without having to without doing it that way. Now, without having to take the measurement. I do take the measurement because I'm drawing these lines using AutoCAD, so for me it's kind of necessary. Okay, so what am I doing first? Well, first thing I'll do is we'll just talk about which of these lines are true lengths in a view. So in this drawing, I didn't label these. I have got a little bit better at using text from my several year hiatus of using AutoCAD for the COVID. We say that the numbers on the top, right? Let me just check. Yeah. Take a chance. Pretty sure I'm using numbers at the top. So 0 and then 1, 2, 3, Z, A, B, C. Okay. So close. Okay. So in our view, I could probably label these points here as well. That's probably a good idea. I didn't do this on the other drawing. I'm probably not going to do this for the other drawing. T 0 and 1 are both in that spot. Up here we've got 2 and 3. Down here we've got Z and A. And then over here we've got B and C. D would also be there, but we're not going all the way across. That's close enough for us. Okay. So if we're looking in this view, we're just going to talk about which ones of these are true lengths and which ones are not true lengths. So we're going to label the true lengths in this fluorescent green. You know what, we're going to copy this because, oops, jumped ahead. We're going to copy this because the colors I'm using specific meanings for things. Okay, so 0, 1 is a dot in this view, so it is true in this view. Okay, 1, 2 is, we're looking at it, it's flat to the camera in this view, so it means that it's true in this view. Okay, 2, 3 is a dot in this view, so it's true in this view. If we go around the side, okay, 0Z is, it's flat to the camera, like it's, no, yes, it's flat to the camera in this view, so it is a true length. 0Z is a true length. ZA is a true length because it's a dot. ZA is a dot in that view. AB is flat to the camera in both views, and BC is flat to the camera there. So they're all true lengths. This is not a true length in this view. 1A is not a true length in any view. 2B is not. 3C is not a true length in any view. The advantage we have is that they're all the same. So that they're all the same. So I think we've labeled those as being, yeah, okay, they're not exactly, sorry, they're all not the same length because this thing here is long. This side here I've done as a light blue, and here I've done the back side as cyan. So that gives us those colors, but those two are both cyan. So I haven't labeled them both in the same color. And yeah, so the true lengths that we're going to need are these corners, the 4 corners, and then these 2 lines that we're going to use to triangulate those positions. Now that we've talked about this, so I can show in red where the things we have that we don't have as true lengths. So we don't have that, we only need that once. We're going to find this, and then 2B and 3C, they're the same. And then we're going to find this, and to help us locate point 2, and we're going to locate point B. That's what we're going to do in this drawing. Okay, now that we've done that, let's have a look over here. So we've said earlier that, what's this size? 1, 2, that's a true length in this view, so we can just measure that off. And we've said that 0Z is a true length, so we can just measure that off. So we've got those lines there. We've got yellow as our seam, right? These 2 lines are parallel to each other, but they're not parallel to the base, but they're the same, and I've marked them as here just so that we can know what's going on. Okay, so what we're going to do is we're going to produce this block. Now, I've already produced the block, but what we might do is I might just take off the, I'm going to take off the lines. And we can see how we would produce them in, and here what I'll do is I'll label them when we get to it. Okay, so I've drawn this twice. Now the reason I've drawn it twice is because I can't just use a compass to measure these distances. I have to actually know the distances to draw my arcs. You don't. So what we need to do is we need to find light blue, bright green, mint green, and cyan. They're the 4 lines that we're going to find today. So what we can do is we can say, well, for the light blue, we'll start, because that's going to be the first non-true length that we're going to have to find. So light blue is going from this baseline, right? It's going from A to 1, right? That's where it's going, from A to 1. Now, the A is down the bottom. All the letters are on this red line, but 1 and 2, 1 is 0 and 1 are up here, 2 and 3 are up here. So because we're going to the height of 1, we're going from the letters, right, from the Z line. That's what we might just quickly label these. I'm not going to label them later, but for the moment I'm going to call this Z, and we're going to call this one here 0 and 1, they're on this line, and then this line here is 2 and 3 are on this line. Okay, so because we're going from a letter to the height of 1, we're going to draw the line. So what we're interested in is the height from here, from A to 1 is that height. We've got that height covered. That's what we can see. What we can measure from the front view is heights. The top view gives us this distance. So what we can do is do the bird's eye distance here. So we've said that's 22.4. So what I'm going to do is I'm going to measure out, I'm going to draw a line that's 22.4, and then I'm going to draw that down here. And that gives me that light blue line. Okay, so now the next line we need is this green line. So the green line is going from A to 2. So we're going from the letter line, A to 2. So the 2 line is higher than the 1 line. So that's why there's that difference in height. Now, it's the height is the difference from Z to 2 is the height. And then the bird's eye view gives us our distance. Our bird's eye distance is 41.2. So I'm going to draw that line here and go 41.2 and down here. And that will give us this green line, right? So that's our true length of that green line. Now, we're going to go from here. The mint line is going again. So let's find the letters. It's going from B to 2, or 2B. So it's going from the B, the letter line, B. Actually, you know what? I'm going to rename this. This is A, well, Z, A, Z, A, B, C. All of those letters are on this line, the letter line. So we're going from B to 2. So from B, which is on this line, to 2, that's the height. And then the distance in the bird's eye view is 36.1. So we're going to draw a line. We're going to draw a line that goes 36.1, and that is going to be our distance in the XY direction, and this is distance in the height. And if we take the hypotenuse of those two, or we could just measure it using our lines, that gives us our mint green line. The last one we have is our cyan line. So cyan is going from C, which is again the red line, to 3, which is again the top line. I'm calling that the gold line. So what I'm going to do is, well, that's the same length as blue, right? So it's going to go to 22.4, but we'll just draw it out again, 22.4, and then down here, and that will give us our cyan line. Now that we've got all those lines, whoops, I do hit that key a couple of times. Now that we've got those lines, what we want to do is we just want to measure them. So the reason I want to measure them is because otherwise again, you don't need to measure them. I need to measure them because I'm not using a compass. Okay, so we've got all our true lengths that we're going to use to draw this diagram. So what we've done here is we've got our diagram. This is our test one that I've already drawn. So we're going to start by drawing the seam. Now, I think they've given us the seam, and that's not uncommon that they'll give us a seam. I'm just going to make these white. And just to help me to be able to see these quickly at a distance, I'm going to color them just so that I know what's going on. That's mint. Oh, geez. And then that one is bright green. Okay. What was that one? Cyan. Okay, just so I can measure them quickly. So the first thing I'm going to do is I'm going to draw this all in white. And we're going to go, first of all, we're going to draw the seam as being 36.1. 36.1 down. Now, the thing is, because in this case I know that 0, 1 and ZA are parallel and 90 degrees, I shouldn't have to show you this again, but I will. This line here, so the corner 1, 0, Z is perpendicular, and AZ 0 are perpendicular. So I don't need to measure that. I can just draw them straight out. Now, the distance, I did know the distance is, I think it's 10, but quickly just measure this distance here. Of course it's 10, and this one is 20, of course. Okay, line 10, line 20. Okay, that first piece is closed. Like I said, I think that's probably, if I was marking a question like this, I'd give that 2 marks. Okay, so the next thing we're going to do is, if we've got 0, 1, 2, we're now trying to find point 2. Now there's 2 ways that we need to get to point 2. So we're going to go from 1 to 2, and we're going to go from A to 2. So from 1 to 2 is 20 millimeters. To draw that, we're going to draw an arc from the center that is 20, and it's going to be somewhere in that ballpark. Then we have to go from, now I'm going to remove the values here because I think that's a little bit confusing. What I'm going to do is I'm just going to draw those as lines. So this one, these lines are both cyan. This one is light blue. The distance from here to here, 41, is bright green. And this one here from here to here, 36.1, is, there's a little bit of rounding because I've gone to the nearest tenth. There's a little bit of rounding, but that's definitely, I mean, you're going to be drawing these with compasses, so it's going to be, don't worry too much about that. Okay, so what we're going to draw from, we're going from A to 2, and from, this is point A to 2 is somewhere up here. We're using the cyan line, so it's going to be 57.4. So we're going to draw a line, we're going to draw an arc from here, which is 57.4. 57.4. What have I done wrong? Arc from the center here should be from point A somewhere up here. I have drawn this one up the top wrong. So this one here, my center, that one there is wrong. Let me just prove it. From here to here is 57, and I've drawn it. I've taken the wrong value. I have taken, right, you can see here, I've drawn my one as 41, whereas it's actually 41 is that value, and that's why I deleted those, because I was worried I was going to make a mistake. So this is not going to help us to model that. Okay, well, we found our point of intersection right there. That's 20. It's pretty pretty crazy turn, but I've got to go with it. Okay, so from here we're gonna find, having these labels actually really does help. Okay, we're going, so we have 0, 1, A, sorry, 0, Z, 1, A. So now what we're going to go is go from A to B. So from A to B is 60 mil away. So we're going to draw an arc from the center here that's 60 and somewhere in this line. What we're going to then do is we're going to go from, this is our point, we're going to go from 2 to B, and 2 to B should be 45.8. Bit crazy. Okay. Yeah, I mean, I guess if you fold that, that's going to make a pretty tight corner. It does have that trapezium shape. I mean, if we push this here, we can sort of see what it looks like if we're facing it as a 2D object. Something like that would be the facing of it. Yeah, crazy, but we can live with it. Now, the next one we're going to go from is from point 2. So this is 0, 1, 2. We're going to go from 2 to 3. So we're going to draw an arc from the center here that's going to be 20. And it's going to be somewhere there. That gives us line 3 is somewhere on that point. If we know where this is B, so from B to 3 is this mint colored line. So it's 53.9. So 53.9 gives us that point. Line from, why is this? I'm just going to clean up this. Just check this distance. Should be 20. Okay. Okay, so that's 2 to 3, and then from 3 we want to find C. So C is going to be somewhere on a line here. C is the same as this cyan line, so it's going to be arc from the center. That cyan is 45.8, 45.8. It's going to be somewhere along there. And the distance from B to C is, we generally draw them as red lines, is 40. Sorry. Okay. Now, a test that we can do to see a bit of a sanity check is we can see if these things are parallel. And what I want to do is extend those and say, that looks pretty parallel. So because we know that 2, 3, and BC are parallel, it is nice to have that as a sanity check to say, okay, well, at least we got that right. So I know where I made the mistake, and it's a shame that I got, because I'm going to have to redo the colors and things. But that is the answer. I'm not going to color it in or label it because I've got plenty to do in this. That we've used half of our lesson on this drawing, and that's probably what we expected. I did have a more extensive version of this drawing, which I might come back to. For the moment, what I'm going to do is we're going to look at 4C. Now, when I say I have got a more extensive drawing, we can see, you know what, it probably doesn't. Oh dear. 4C. Well, okay, well, so this is the more extensive one. Sadly, that's still wrong because I've used a distance that's much too short here. This part, this shape here looks right. If we can see that shape there looks right. The problem I've done is I've made that one mistake. Now, I'm not a marker. I can't say if for one line, because I've got one line wrong, how much that, because obviously if you put the overlay there, you're not going to get it. A 4-mark question, you shouldn't be getting that correct, and especially in a trial, I would mark that wrong because I want people to learn. In the HSC, you're probably getting 3 out of 4. That seems like would be the fair answer, that you're getting 3 out of 4. I will say that I don't think that there are many people who are even going to get this level of answer because, I mean, I made that mistake, and it's pretty easy to make one mistake. So I imagine you could have even a minor error. If it was worth more than 4 marks, if this was worth out of 5, I think that that'd actually be more likely to... Anyway, moving on. So what I've done here is I've shown you that there's other ways that I've used to determine these lengths, right? So what I typically do is, this is the way I learn, is rather than drawing them as a separate little diagram here, like this, what I do instead is I like to rotate the object until they're flat with the camera. Right, so I've taken the bright green line and just rotated it until it's in line with the camera, and then I've measured the distance from there to there, and I just find it's a lot easier to find the drawing, to find the distance. So this blue line, I've rotated until it's flat with the plane and the viewing plane, and then I've extended that line. You can see I've just moved it out a little bit just to extend it. Right, the green one I've just extended a little bit, whereas now, what I've shown you here is don't do this, right? So what I've done here is I've rotated the mint green out to here, and then I've drawn down and then said, okay, well, that must be the new length of the green line. It's not correct. The reason why that's not correct is because the line that I've rotated, you can see that I've gone from the top to the bottom, and I've rotated the bottom out. So it's the bottom that needs to move, not the top. So this is wrong, right? This is what I've drawn here. This is wrong. I've deliberately drawn something wrong so that you can, because I found myself drawing this, and then I thought, oh wait, that's wrong. And I thought, well, this is a good opportunity to show you that's wrong. Don't do that. What we're going to look at instead is, so what we've done is we've rotated this object out to here. And then what we've done is we've extended the bottom, and that's why we've got, this is the line that is the most different from what we've measured. I mean, we can see this here is a little bit different, but from the line that we would have just drawn, but here we have a big difference. So that's that mint green line, and I don't even know why I have this here. Oh, this is just showing how I've measured out the light blue line. Anyway, so that's that one. What we're going to look at now is another object. Now you can see I've drawn lots and lots of stuff here, but that's just because I want to be complete. You know, it's because I want to be thorough in what I'm showing you. Okay, so what we're drawing this time is this object here. And I am inclined to rotate it because when we build these shapes, we kind of sort of look at them from the objects, and the fact that we kind of go around the back means it looks a bit odd, but you know, we're going to stick with this letter because in this view, the letters sort of make a bit more sense. If I'd rotated the letters all around 180 degrees, then it would make more sense. Okay, so we've got, we're sticking with the convention of the seam being 0Z, 0, 1, 2, 3, and Z, A, B, C. We're only going to draw that many sides. That's typical. We don't expect you to draw the whole object because there isn't the time, and you've demonstrated enough knowledge. Now, remember that these bottom versions, I would never draw this many bottom versions. The reason I'm drawing these all out for you is because I want you to see how I would measure out each of these lines, right? So the first thing to measure out, and some of these are duplicates which you don't even need. It's just me being overly fussy, and I didn't want to make a mistake, and even though I made a mistake on the other one, I'm pretty confident this answer's right. Let's fingers crossed. Now, I don't have a nice clean version of the question, so I'm just going to bring this in and say this is what the question looks like, and this is what I've got here. So I do have these colored lines around the outside. Oh, you'll notice also that I drew what it looks like as a side view. I don't need to do that. I just do that to help me. And now I don't know if I'm going to label this, but it has been helpful to label these. You can see where I've got these lines from. I think that's worthwhile. I mean, this is labeled, and that's enough. Yeah, I think this is enough. This is my my 3D model, but I think that'll do. Okay. So, yeah, I mean, it would be better if this was. I'll make this all white. I'll copy it just in case, because you never know. On the sait jamais. This is how you end up getting 10,000 of these things, because it cost me nothing for me to draw another one. And okay, so that's what we've got as our drawing, and what we're going to look at is this one here. So I've colored all of these things to help me know what's going on. I'm not going to label these as being true lengths or not, but we can do that really quickly and just say what is true in this view, right? So we have this seam. That seam is not shown here. The seam is this line here. That is not a true length, right? Because it goes away from the page. It goes into the page here, and it goes away from the page. In both of these cases, if we're drawing against a piece of glass, in both cases, this line is moving away from the viewer. So it is not a true length. The seam is not a true length in either view. Really important there, right? We can't see the seam, but the seam is not a true length in either view. This here is a true length, right? So these two lines on either side, they're both true lengths. The outside rectangle is a true length, so it's kind of the colors I have here, right? The colors that I've labeled, they're all true lengths. So all the red lines are true. The gold line is true. The magenta line, they're important heights, so I'm going to refer to that height. So there's the magenta height is the height of, we'll label that over here, right? So what are our lines? Well, this is our magenta line is the 3 line, right? So the magenta line is where our 3 is. The yellow line is where our 0 is. And then the gold line is where we have our 1 and 2. How far are we going? Yeah, we're just going to go 1, 2, 3. So we do need this number. We do need, yeah. Okay, we're going to use it for 3. 1 and 2. So, always do that. I just always do it. I'm going to move these. I'm going to move them. Just because it's a bit cramped. Right, so that's the lines. I've given them colors, but just so you know the height that they're referring to. And of course, this line down here is going to be our Z line. It's Z, A, B, and presumably C. Okay. So, before we talk about how we're going to measure out these lines, the first one is we're going to start with yellow, right? Because the yellow line, the seam, that's the trick. That's what gets people. That's what they're really easy to make that mistake. I'm not saying I made that mistake this time around, but I probably made that mistake. I know I definitely made that mistake last time. So that's really easy to make that mistake. So what we're going to look at here is say, well, this line, it's not flat to the camera here, and it's not flat to the camera there. So let's rotate it so it now is flat to the camera. So we've rotated it until it's in line with the viewer, right? And now by rotating it, it doesn't matter if we go front or back. It doesn't matter which one we've gone to, but what we've done is we've rotated the top of the object. We've moved, so we're moving the top of the object until it's flat with it's in parallel to the viewer. And now what we can see is that this is the true length of that seam, right? Is 36. So that's how we did yellow. Let's have a look at how we would do it using the typical method, the way that we typically refer to it. Just to clean things up, just because I've got a lot going on here, I'm just going to copy all this again. As you can see, a bit copy happy. Right. We're just going to strip everything away until we're down to what is essential here, right? So what we've done is we've said, okay, in that yellow height, right, our 0 line, what we've done is we've just said, okay, in the top view, we can measure this distance is 6.6. That's its distance in the top view. Right, so that's its distance in the top view. We can, with that measurement in the top view, right, 6.6 in the top view, we can measure that out, and then we can say, well, what's its height? The height is from Z to 0, and that gives us, if we take those two values, we know the height is 34.9 times 6.6. I'm not going to use my calculator, but I'm pretty confident that if you, yeah, I keep saying, if I had my good calculator in front of me, I would. That's going to give us our value, our distance, which we can then DIM. It's going to give us this value, right? That seems like, just checking it, it seems like a reasonable value. It should be a little bit bigger than 35, and it is. It's exactly a little bit bigger than 35. So what we're going to do is we're going to have a look at these other lines. So if we look at our drawing, so the red lines we can just measure off, the gold and the pink line we can just measure off as needed. We're going to use these lines later as well, but they're true lengths because this is flat to the camera, right? It's not going in or out of the plane. We can measure those two values, but let's just have a look at so we've just done the seam, the yellow line. We've got to do this, the bright green, we've got to do the cyan, we've got to do the mint, we've got to do, I call that sort of dark blue. We've got dark green and we've got light blue. They're the different lines that we're going to deal with. So what I've done is, because I can't look at all of those at once, I've drawn multiple drawings just so that I can measure them and see them clearly. So here we've got our blues, right? So what we've done here is we've just drawn this line up again. And I've said the distance from here to here is 12.5. And you can look across at the top of the drawing, I'll just go over here, is 12.5, right? That's what I had drawn on the other drawing. And then the distance from here is 17.1. Those heights, they're both measured from the letter line, right, from the base, which is always, in this case, is flat across. And it's going from the flat across to, so when we're looking at 17 in the top view, and our height is going from here to here. I don't even know what that height is. I don't need to measure it because I can just measure the height directly off the drawing. So the top view, the front view gives me heights, the top view gives me this distance, and with that distance I can draw these lines. Okay, now for the light blue, the distance here is we're going from, I have to find the letter, C to 3. Right, so we're going from C, which is on our letter line, and then 3 is on this magenta line, right? That's what you can see here. We're on this magenta line, and we've said that this line here was 32.1, which is exactly what I had there. 32.1 is the same. 32.1. Actually, there I've measured 32.3. Just remember there's a degree of rounding. Don't worry about that. I don't know how I've got that error wrong. I must have picked up the wrong line. Anyway, it doesn't matter. And then here we can measure off and get 43.9. Sorry, I was saying the numbers, mixing them up. Okay, so for the green, they're all going to the same height, to this gold height, right? From point 1 and point 2, they're both on the gold line, right? This gold line here. And because they're on the gold line, they're all going to the same. Now, the difference, what we need to measure out is their top-down distance. So we've got 12, 30, 34.9, and 50. We've got 12, 34, and 51. So we've got 12, right? 12, 34, and 51. Right, so that's our different distances. Once we've got those distances, we just measure them off. Again, you could do Pythagoras' theorem if you're keen, right? But it's just so much easier just to do graphical solutions. Now, I'll just quickly address, so we've already talked about the gold line. To do the blue line, what we would do is, so the blue lines. Cyan, we would flick the top back, and you can see that's what we've done here. We've flicked the top until we're parallel to the viewing plane. Here we've gone purple, we've moved it forward until we're parallel to the viewing line, remembering that in both cases we've moved the top of the line, Here again I'm moving the top of the line, but it's still lower. Remember that it's not going up to the gold line, it's going down to the magenta line. Okay, for the green lines, why have I got this one here? I don't need that. That's confused. Okay, so for the bright green one, we're just going from Z and we're moving 0.1 until it's flat with the viewer, so that's 41 there. For the mint, we're going 34.9. We're moving the top, and we can see that's what we've got here. For dark green, we're moving this back until it's parallel to the viewing or the camera. And that gives us this dark green. So the dark green extends a little bit. You can see though the mint green, that really has changed. And this is why if I was in a real rush, I would try and look and guess. This method I think is really useful because it helps us see like how many of these do you really need to, I mean, these were off by a millimeter, that's maybe off by 4 millimeters, right? Whereas this one here is off by stacks. This one is the one that counts. This mint green one is the one that counts. I also found an extra value and this red line. Now the reason I found this red line is because I really wanted to make sure I wasn't making a mistake. So what I did here is when I was triangulating this position, well, okay, let's start making the shape. The first thing I did is I said, well, I've now got the seam as 35.6. So when we do our distance, we've got 35.4. I may have found it as being, it's out by 2, but you know, 0.2 millimeters, I can live with that. Okay, certainly acceptable for the HSC. Now this orange line is 11.1, I think, right? I think I actually did that to the 10th of the millimeter because it's so important. So it's actually 11.18 when I measured it off this drawing, right? Okay, so it's 11.18. Okay, then what we would normally do is because this red line, okay, so the first thing I do is I knew that when I look at this drawing, this seam, move it around, have a look off the back, makes the letters a bit tougher, but when we look at here, this seam, Z01 is not a perpendicular, it's not a right angle, it's not, we can't just say it's 90 degrees. But, so we have to figure out where point 1 is. We have to do that through triangulation. This is the first time we've had to do that. So 0ZA though, that is 90 degrees. That's perpendicular angle. So we can just draw the yellow and red lines just straight up without having to do anything else because we know, actually I didn't need to do that. I have a whole nother drawing. Okay, so you can see how I've just drawn the red and yellow lines just from measurements. The yellow line we've calculated, but the red line I can just draw at 90 degrees. What we now need to do is we now need to calculate, if this is 0, finding point 1 is a bit difficult, right? Normally that's just been a given. In this case, it's not. So what we can do is I've actually not just triangulated, I've found it through 3 different lines. I know that it's the orange line is 20 millimeters away from this corner. This green line is 41.6 mil away. Let's just show you that. 41.7 within a tenth of a mil. And then I also calculated the length of 1A, right? I also calculated 1A. I didn't need to calculate 1A, that's this cyan line, but because that's 41.9, 41.9. So we can, I've actually got 3 different ways of calculating that position, right? I didn't need to do that, but I did just because I wanted to make sure that that first picture was right. Okay, the second, so after that, what we're doing is we're just going about this in the normal way. We're going to find, if this is Z, A, B, we're going to find point B by triangulating off the mint line and this red line, the base, which should be like 40 mil away. Then from there, we're going to go, we're going to use point 1 and B to find point 2. Off point 2, we're going to find 2C and BC are going to triangulate this point, and then once we find C, we can triangulate these points here. Now, a quick point to mention is because the back piece, because A and B and 1 and 2 are parallel, you could, if you were in a rush, you could just say, well, you know, I don't need to triangulate this position. I can just draw 2 lines that are parallel, right? I could just find 2 lines that are parallel and just extend this out. Right? 2 lines that are parallel, and then just measure off 20 and say, well, okay, that's going to be the right distance. That's another option. Okay. Let's make it ourselves, right? So what we're going to do is, first off, we're going to start by drawing the seam. The seam we measured out a couple of times as being 35.6 millimeters. The blue, we're now going to do the red line, the red distance of that seam. What is that distance? I have shown it here. I've shown it here, measured it out as 20.6. 20.6. That's just a true length that you can measure straight off the drawing. Now, what we need to do is we need to calculate, or we need to find position 1, right? So position 1 is 20 millimeters. Is it? No, it's, I probably measured it somewhere. It's 10 millimeters away. Look, we'll just measure it out. It is indeed 10 millimeters away, right? Okay, so what I'm going to do is going to draw an arc that's centered from here, and I'm going to say, well, it's somewhere in the 10 mil mark. It's got to be somewhere there, right? Then there's 2 different ways I could approach this. I could do the bright green line or the light blue line. It doesn't really matter which one we want to do. I've gone to the effort of finding the bright green line and I've shown it, but I really probably wouldn't have. I normally, we need to know the light blue line. Like that one we actually need to be able to produce these things. So we're going to go with that one, which is, we can see here, we've measured out. When we do our process, we get 41.9. So let's just draw an arc from the center is 41.9. It is worth, oh no, I'm going to go from here, 41.9. It is worth pointing out that sometimes having, and this is true of like finding reactions, when you can do things an alternative way, it is useful because what it gives you is it gives you a way of proving an error. The same way that we know these should be parallel, it's a way of proving an error. So like it gives us confidence that we have done the right thing. So now what we're going to do is we've found 1 and A. We now need to find 2 and B. So we're going to find B first. That's how we've triangulated this. We could, if we wanted, and I actually did do this just to check, is I also did A2 just to make sure that I haven't done anything wrong. Now, in this case, they're the same, right? Because it's, no, they're not the same. I tell a lie, they're not the same. Oh, never mind. If this was symmetrical in that axis, it would be the same. They're not. Okay, so we're going to go from B to find B. We need 1B. 1B is this mint green color. So 1B is 53.1. So we're going to draw an arc from the center of this thing, which is 53.1. 53.1. And it's going to be somewhere in this ballpark. Okay, so that's our mint green color. That's what we've drawn here. And then what we're going to do is we're going to, this one here is 40 mil. So we're going to draw an arc that's centered from here that's 40. And we've got our line. Okay, so we've now got B. From B, we're now going to find 2. Now 2 is 20 away from 1. So we're going to draw an arc from the center that is 20 away. And the question is, how far is 2B? Right, we've used that trick many times. 2B is this dark blue line. Dark blue is 43.5, right? So we're going to go, an arc from the center is 43.5. C, 43.5. A little bit of a big arc. Wasn't really what I intended, but I did not want that. That'll do. Okay. Okay, now that we've got that shape, what we need to find is we need to find 3. So from 2 to 3, no, we're not going to find that. We're going to find C first. That's what we've shown. Again, we could have done it that way. We could have drawn the lines in the other direction. I just like finding the letters first. So what we're going to do is we're going to say from 2 to C is the dark green line, this one here, 65. So I draw an arc that is 65 millimeters away from point 2. 65 and somewhere out there. And then I'm going to draw another arc from here that is going to be 60. Right? A arc from the center here that is 60. That's there. Now I can draw that line in. From C, we're going to find 3. So we know 3C is this light blue line. 3C is 43.9. 43.9. And then the distance is 20 mil. Arc C, 20 mil. Ooh. Don't like that. Will they intersect? If they don't intersect, we've done something wrong. Yeah, they don't intersect. What have we done wrong? Okay, let's just check that 2, 3 is a true length. So let's just find the dimensions of that. 20, right, that's fine. Okay, so that 20 line is correct. What we have said here, that this one here is 43.9. Um, 43.9. That's 60 away. The dark green from 2. Just checking we've got this right spot. This is 65. Yeah, that's 65 away. Just check that this is 60 away. Yeah, that's triangulated correctly and it looks right. Just check that. Redraw that arc. I mean, arc from the center of here. It is indeed 43.43. Okay, great. Now, look, there's a couple of things to talk about. I mean, getting things wrong when we're doing a video is, I mean, obviously, we'd love to have videos where you don't get anything wrong, right? That would be the ideal. But the thing is, there's a real learning opportunity, right? There's a discussion that we can have about, well, what do you do when you make a mistake? You know, I'm not going to clean that. Okay, so what I figured out is that this distance, it's not a true length. 2, 3 is not a true length. 2, 3, this is the true length. It's a true length in one view, but it's not a true length in that view. Now that's because I'm drawing so many of these objects that they sort of, you know, mesh together. But it's really important that, but here's the advantage of it is we've made a mistake, but we were able to see that something was going wrong, right? We could see that something was going wrong. There was something that's helped us to spot the problem. But what would you do if that hadn't worked? Well, if it had been me, I probably would have. I mean, you can't just leave the drawing. You can't just, you can't leave it unfinished. You want to take a crack at it. So if you're going to make an assumption, just draw the lines out a little bit bigger. I mean, it's fudging, but you want to show the marker that you've got an understanding of what's going on. And you wouldn't do this in professional practice. You would, go and ask a boss, and someone would give you a hand, or even someone who will give you a hand. But it's also worth pointing out this, right? That there are sometimes two locations where these things, often there's two locations where this thing meets. And you've got to use your, the reasonable intelligence of which one it's going to be, right? That's another consideration. So two things worth talking about there. So I have talked about how we got these distances. I just said, so this red line is I only showed because it's an alternative way of triangulating. So this is going from 0 to 2. No, 0 to A. 0A. So if this is 0, yes, it's another way of getting this point. So the same way that we triangulated here, we should be able to check that that's 41.2. This line here is 41, right? That's what we're looking for, right? That we can just check that line is correct. We didn't need that line, but it is handy if you've got extra time that you can actually triangulate with more points. Just be careful that if it's not working, we'd rather you show something. We'd rather you demonstrate some knowledge than no knowledge because you just panicked and didn't do anything. Be careful that there are 2 points where these lines meet. You have to use your best guess. If you really wanted to prove that it was in fact this line and not that, so what we could do is we can measure from here to here, and that's how we can confirm the correct triangulation, right? So what I can find out is what's B3. Now, I don't need to calculate B3 because I can just measure off my 3D model, right? I'll just show you here. I can go from B3, just do the distance from B to 3 is 44.9. And then I can draw an arc A from here, 43.9. I think it was 43.9. Let me just check that. It's the same model, it just viewed 44.9. There we go. Makes me feel better. 44.9. Oh. It's pretty close to the... I actually... Because I'm snapping, it missed a little bit. It's within 1/10 of a millimeter. So keep in mind, when you draw these, you're not going to draw these perfectly accurately either. It just, that inaccuracy becomes a lot more apparent when I'm also doing a lot of rounding. So I'm rounding to the 10th of a millimeter. So those things are why we get very close to being perfectly triangulated there. So there are still harder questions than this, right? So how this question could have been more difficult is, with all of these questions we've done so far, we've always had this line be perpendicular to the base. What we could have had though is let me just make it a little bit more interesting. We could have done an object like that, and we can have an object where we've got no flat line, and so it means we have to measure all of our things from, and so see how our Z, A, B, C line is being flat in all of these drawings. If we don't have that, we then have to consider, we have to draw it out separately. We have to draw it out with different lines, and that was kind of like what we saw in that 2017 question. But this has, I think, been are really exhaustive. This is as much as I've ever gone into true lengths. It's a great thing to maybe do in graphics, but for year 12, we do normally run out of time, and just that, we normally focus more time on study. In this case, because I normally wouldn't have drawn these on AutoCAD either. That was really the big difference for me. And although painful initially, it does give me the benefit of all these colors. So rather than having to label things, we can sort of see where lines have come from and draw things. And in this case, that pink line really did make the difference. That I thought, why is that not orange? And it reminded me that no, it's because it's a slightly different distance. So hopefully that was worthwhile, and good luck.